Hi and welcome back to my channel. Today we're going to be looking at the medical scientific background behind Spider-Man and whether it's applicable in real life. My name is Dr. Miranvir Singh. I'm an emergency medicine specialist here in the UK, and so let's get into it. So as you can remember from Spider-Man the films, Peter Parker always starts off in the lab, and you can see from this clip here, and he sees all these different spiders around him. They've all been genetically enhanced. They have all had something done to their DNA, which is the basic structure for all life form. These spiders are therefore genetically enhanced with super abilities and superpowers. And as you can see from all of these films, Peter Parker ends up getting bitten by one of these spiders, and then later on starts to get side effects. He starts to feel ill, sick, unwell, and then passes out. And then when he wakes up, he finds out that his body's got new muscle mass to it, he's got new strength, abilities, and certain other powers which are very specific to him being Spider-Man. In this clip of Tobey Maguire, who played the original Spider-Man in the first Spider-Man film, you can see he's got that classic wheal rash that's occurred on his hand where he got bit by the spider. This is classic of what we would see by an insect bite that would occur in real life. So this is very accurate. The side effects that Tobey Maguire's character Peter Parker gets are very classic of what you might get when you are suffering from an infection and having a very high temperature. So the shakes, feeling cold, sweating, rigors, which is the shakes, and just generally being very unwell. And as you can see from that diagram there, the spider's new genetic code has been encoded into Peter Parker's DNA, and this is what is supposedly going to be giving his new powers and new abilities. And when he wakes up, you can see him checking out his muscles and flexing. His eyesight has completely returned to normal, and that's because he's got new powers and abilities, and then he's flexing his muscles and he's got new muscle mass. And that's because we know that most insects, such as spiders, are very strong in compared to their body mass and body proportions, and they can actually carry many times their own body weight. So some useful and fun information: the strongest spider is the Darwin bark spider. It can lift up to 80 grams, and this is ridiculously impressive considering the fact that the spider itself only weighs half a gram. The spider silk itself is also twice as strong as any other spider species known to humankind, and as we all know, silk for its diameter is stronger than most steel. So this spider can lift 250 times its own body weight, easily more than any human can, and breaks the human world record for powerlifting. But still, the spider is not the strongest animal within the kingdom world. The dung beetle can actually lift 1,141 times its own body weight. That is ridiculously impressive. That would be like a human carrying 80 tons of weight. You'd literally be crushed. So is this possible for a human being to encode other genetics within their body and then gain these kind of superpowers? Well, actually in 2012, a goat in the USA was encoded with the spider's genetic code for producing silk, and the goat was able to produce milk that contained the spider's silk protein. But unfortunately, it wasn't a case of simply squeezing the udders to get the silk to come out like Spider-Man's web shooter. Instead, it was the protein was actually within the milk, and then that had to be sifted out, and the protein had to be collected from the milk, and then the proteins themselves would then be combined together to produce the spider silk. So far, the technology for encoding that kind of DNA to produce what we can see on film doesn't exist. But potentially at some point in the future, that may actually occur. So then we move on to the fun things such as the ability to stick to walls. Now obviously with spiders they have these very tiny microscopic hairs which allow them to grip and stick onto different surfaces. So far there's nothing in the world that exists which would allow a human being to do that, and especially in proportion to our body weight, it would make it very difficult just to have very fine hairs on the base of our fingertips or feet in order to be able to do that. The closest thing that we have are things which are similar to what a gecko would use to be able to stick to surfaces. In one of the latest Tom Cruise films for Mission Impossible, which uses some kind of charge to create some kind of static force which is allowed to be turned on and off. There's nothing like that actually in existence. That was just made for the film, but actually at some point there will be someone who's very clever who will be able to create something like that. Now with regards to web shooters, we've covered that slightly, but actually nothing exists at the moment that can be shot from a small device on the wrists. Now, a spider also does not shoot its web. It actually creates the web very slowly. It actually creates the web which are located within glands within the spider's abdomen, and these are called spinnerets. So the silk is actually made up of multiple different proteins, and the proteins then are combined together to form long filaments, and these filaments have microfilaments attached to them. So it's not just simply just one simple thread. It's actually multiple hundreds, if not thousands of threads which are wound around each other. There are areas which they are unlinked, and that's what gives the spider's web flexibility. So the silk is produced from the internal glands within the spider's abdomen, and it's produced in a soluble form. That then comes out of the spider in a hardened form, and the spider uses its spinnerets as well as its legs to create the shapes and designs that are required for the spider to spin its web. Now, the spider silk is about 1,000 times thinner than a human hair. It is also about 5 times stronger than steel. Now, something from a scientific point of view is that we have now come across a new material known as graphene. So graphene is a substance that was recently found, and the reason why I mention graphene is because Australian researchers actually found ways to make graphene into fibers, and they used that to make a mesh which was stronger than Kevlar. Now, graphene has many different fantastic properties. Upon them, it's ridiculously light and it's ridiculously strong. It's 100 times stronger than steel, it repels water, and it's highly conductive. So imagine if that was made into a spider's web. This could actually be used in terms of a point to create something like what we can see in Spider-Man when Peter Parker is making his web shooters. Well, I hope this video is informative and interesting. Remember to like, share and subscribe. Let's grow this channel. I've got some more videos coming out to do with Marvel and the science behind it. So remember to watch out for that. Look after yourselves, and I'm going to see you all in the next video. Thanks for watching.